Welcome to Calculus. We've taken a look at three examples of taking derivatives of trigonometric functions. Let's take a look at two additional examples that involve now differentiation of secant and cosecant. So we've got our four rules here. Our function we're trying to take the derivative of for this example is y equals x times secant of x plus the square root of 2 times cotangent of x. So the one rule that I don't have recorded here in my table is the derivative of tangent of x. I'm sorry, of secant of x. So that's that last entry in our chart. Let's go ahead and say what that derivative is. So d dx secant of x is going to be secant of x times tangent of x. So for these cosecant and secant, notice for secant at least it starts with itself times the tangent. So now we're ready. That gives us enough differentiation rules to find y prime. But what I notice first here is that x secant of x is a product. And so again, what I need to use here is the product rule. So just to write the product rule again, if I've got a function big F of x and it equals small f of x times g of x, then the derivative of big F of x is going to have this pattern. Small f of x times the derivative of small g of x plus small g of x times derivative of f of x. So I need to use that at least for this first term in my function. Let's identify in that first term what's my f of x, what's my g of x. So this first factor x, that's my f of x, which means the derivative of f of x, derivative of the linear term, is going to be 1. Let's also identify g of x here. So g of x is secant of x, and the derivative that we just recorded in our table of secant of x is going to be secant of x times tangent of x. So as I start to take the derivative of y, so y prime equals, I'm going to fill in for this first term. Again, that's just for x secant of x, putting my pieces here into the product rule. So it's going to be the small f of x, which is x, times the derivative of g of x. So that's secant x, tangent x, plus original g of x, which is just secant of x, times derivative of tangent, which is just 1. And then I want to pick up with differentiation of that second term. So that square root of 2 cotangent x, that doesn't have any part there that's a product or a quotient. So I'm just going to use the constant coefficient rule, leave the square root of 2 in place, and then take the derivative of cotangent, which I see from my table is negative cosecant squared of x. And that completes that differentiation. I'm going to write it again in a one unified way. So from this first one, I can just write x secant x tangent x plus secant of x and then minus, I'll bring that negative out front to become minus square root 2 cosecant squared of x. The only part there that we could consider simplifying would be here with secant x tangent x. So we can just check secant is 1 over cosine, tangent is sine over cosine. And so I don't see any cancellations there. So we'll just scratch that and box what we've got as the derivative of y. So final answer there, x secant of x tangent of x plus secant of x minus square root of 2 cosecant squared of x. So that involved a product of two smaller functions there in our first term. Let's take a look at one last example. So here we've got a quotient set up. So our function y is equal to cosecant of t over 1 plus t cosine of t. So I do see that I've got a quotient set up. So remember, our quotient rules would say if I've got a big function, we'll call this f of t since t is my independent variable here, that is small f of t divided by small f of g. So notice the similarity between the product and quotient rule again. If I took the derivative of that quotient, so derivative of big F of t, what that would equal is another fraction that would start with the original denominator g of t times the derivative of small f of t minus original small f of t times derivative of small g of t all over original denominator g of t squared. So that's my rule. So what I want to do again is just apply my rule to what I've got by just figuring out, first of all, what's f of t, what's g of t. So f of t, that's going to be my numerator cosecant of t. So that means my derivative of f of t, if I look in my table, is going to be the one that's missing. So we need that cosecant of t. Well, let's fill that in right now. So cosecant t is related to the derivative of secant. So if secant was equal to positive secant tangent, derivative of cosecant is negative cosecant cotangent. And that will help me fill in my first derivative on my quotient here. So if f of t is cosecant t, derivative of f of t is going to be negative cosecant t times cotangent t. And what that leaves for me is g of t is this sum down here, 1 plus t cosine of t. When I go to take the derivative of small g of t, that original denominator, I run into an additional kind of hiccup here. It's really this second term, t cosine t, which is itself a product. So I can take the derivative of 1 there, that first term is going to be 0, but then for the derivative of cosine t times cosine t, I need to set up for the power rule. I'm sorry, for the product rule. So if now I'm going to, again, kind of use two separate ones. So my small t here, let's call that h of t, which means the derivative of h of t is going to be 1. And then we'll set up for, let's call it j of t. So again, I'm just kind of flipping through my variables so I don't confuse with the quotient rule f and g here. So I'm now using the product rule h and j. So j of t is that cosine of t, which means the derivative of j is going to be negative sine of t. Again, we're doing this because I got to fill in now for derivative of small g of t, the original denominator. So I'm going to fill in based on the product rule. So it's going to be plus h of t, which is t, times the derivative of j. Should put that prime there so it's clear that's the derivative. So negative sine of t plus original j, which is cosine of t, times the derivative of h, which is just 1. Let's simplify that derivative of g of t. So 0 is going to go, it's going to be equal to negative t sine of t plus cosine of t. And now we're ready to fill into our quotient rule, now that I have my 4 parts from the original quotient set out. So let's start writing our derivative. So y prime Remember, the quotient rule sets up its derivative as another quotient. And we'll fill in here based on our color coding. So f of t is going to, actually we start with g of t. So let me pick up green. It's going to be 1 plus t cosine of t times the derivative of f, which is negative cosecant t times cotangent t, minus original f, which is cosecant t, times the derivative of g, which is what we just calculated, negative t sine of t plus cosine of t. And that's all going to be over, if I extend that line so that it covers that whole numerator, over the original g of t squared. So that one I'm not going to do anything with. 1 plus t cosine t squared. So again, I could just box that, but my feeling is there's probably some cancellation. So what I want to do is I want to distribute the numerator and see if I can reduce it. So we'll just put an equals, and we'll put our fraction bar again. And again, we're looking for some cancellation. So I'm going to distribute this whole piece in red to the 1 and to the t cosine t. So that's going to be itself basically negative cosecant t cotangent t. And then I'm now going to distribute to t cosine t. So that's a negative sign. And a lot of multiplying here. T cosine t cosecant t cotangent t. So 3 trig ratios in a row multiplied there. Now for the second part, I want to distribute negative cosecant t to each of these two terms in the derivative of small g. So negative times negative will be positive t cosecant t times sine of t, and then minus, because there's a negative from the cosecant t, positive from cosine t, and then I'm just going to put those in a row. I'm here in my table, but I'll make it work. Cosecant t times cosine of t. And that's all over 1 plus t cosine t squared. I'm not going to change that denominator because that's what it is. For the numerator, though, I need to decide like what's going to cancel. So let's take these pieces term by term, and we'll just kind of zoom in here to see what we're dealing with. So from these first terms, I'm just going to investigate what would take place if I reverted and called cosecant cotangent something in terms of sine cosine. So recall cosecant is 1 over sine, and then cotangent is cosine over sine. So I don't see much cancellation there. So what I'll do is I'll just keep what I've got, negative cosecant t cotangent t. Now let's investigate this next term, which has 3 in a row. So it's cosine of t. So that I wouldn't change. That's just itself. Cosecant of t is 1 over sine of t. And then cotangent is cosine over sine. Now, what I'm seeing is that I have really 2 cosine factors in the numerator, 2 sine in the denominator. So the way I'm going to kind of bundle that together is that is equivalent to, let me circle it, cosine squared t over sine squared t. And then I remember cosine over sine is cotangent. So that's really cotangent squared of t. And so I'm going to start, what I'll start doing is I'll start building that final answer. So y prime equals, if I bring my fraction line again, remember the first term I didn't change, so negative cosecant t cotangent t. But that middle one, I can reduce to negative. There was a factor of t out front, cotangent squared of t. That really reduced it down a lot. Now for that third set of products, so I got t cosecant t sine of t, that third one. So again, I'll call cosecant 1 over sine, and then sine is just sine. That's a nice cancellation. Really, my two trig ratios are canceled to 1, so what's that left is just plus t times 1, which is just plus t. And then I had one last product here, minus cosecant times cosine. So again, cosecant's 1 over sine, and cosine is just cosine. So that's cosine over sine, which is going to be cotangent. So that last piece would reduce to minus cotangent of t. So I still have 4 items there in my numerator, but they're reduced down substantially, and that's over 1 plus t cosine of t squared. And that is y prime. That I'm going to box. That is reduced. So thank you for joining for this 5th example of applying the trig differentiation rules. I'm going to let you go practice on differentiating your own trigonometric functions. Thanks for joining. See you soon.